All right, it says to use the rules for exponents to simplify the expression. Assume the variables represent non-zero real numbers. Remember, the only reason we do that, worry about non-zero real numbers, is that we can't have 0 in the denominator. It says to type the answer in exponential notation using positive exponents. So we don't want any of these negative exponents in our final answer. Well, the first thing we need to do to simplify this is to get rid of the parentheses. And we can do that using this power rule, which says that if you have a power raised to a power, like x to the fourth raised to the fifth power, you just multiply the exponents. So in this case, you'd get x to the 20th. Well, over here in our problem, what we have is m to the fifth raised to the negative 3 power. So we'll multiply the exponents. The 5 times the negative 3, which will give us m to the negative 15. And then we multiply this exponent, which is just a 1. We don't write the exponent down when it's 1, but there's a 1 there. Multiply that exponent times this exponent, and we'll get n to the negative 3. Now notice the exponents in the bottom are not raised to this negative 3 power, so there is no power rule to use down here. We don't use a power rule. Let's just bring those down, or bring those across. M to the negative 13 times n squared. All right, now the next thing we should do is get rid of those negative exponents. And we do that using this little rule that says this. If you have m to the negative 15 over m to the negative 13, all you do to make those negative exponents positive is to just to flip them, basically take the reciprocal. The m to the negative 15 will become m to the positive 15 in the denominator, and the m to the negative 13 becomes m to the positive 13 up in the numerator. So we do that, and we can do the same thing with this n to the negative 3. We can make that positive by bringing it into the denominator. All right, so what does that leave us with? We will end up with, taking care of the m first, m to the negative 13 comes to the top as m to the positive 13. M to the negative 15, I'll go to the bottom, is m to the positive 15. Now there's already an n squared down there, so n squared is a positive 2 exponent, so it didn't have to be moved. But this n to the negative 3, to make that negative 3 positive, we bring it to the denominator. So essentially we flipped everything to make the negative ones positive, the negative exponents positive. Now we can do this. We can simplify the n squared times n cubed as follows. Keep the m's in place right now. The rule for multiplying exponential expressions that have the same base, so n squared times n cubed, is to add the exponents. So this would give us n to the 5th power. The 2 plus the 3 is the 5. Now we're almost done, but we have this m to the 13th over m to the 15th. So there are m's on top and m's on the bottom. And the way we can simplify that is, let's take a simpler example. Let's suppose we have x cubed over x to the 5th. Just for a second, look at this. If we multiply out x cubed, we got x times x times x. And if we multiplied out x to the 5th, we'd have x times itself 5 times. Now look, we can cancel this x with this x, this one with this one, this one with this one. Well, what's left? Well, what's left on top is 1. Remember, there's still like times 1 up here, so there's always still a 1, even when everything else cancels. And on the bottom, there's x squared. Now, we could have gone straight from here to here by just observing that, well, there's 2 more x's on the bottom than on top. So when all the ones on top cancel with the 3 of them on the bottom, there's still 2 left over. The same thing happens with the m. I just, instead of writing out m 13 times on top and 15 times on the bottom, just recognize that I'm going to cancel the 13 m's on top with 13 of them on the bottom. I'm going to still have 2 m's left on the bottom. On top, we're going to have a 1. And then we still have that n to the 5th. So it ends up being 1 over m squared n to the 5th. And as instructed, we don't have any negative exponents. And so that's our final answer.